All right, I'm back again. Thank you so much for exercising your patience to wait for this time, despite the fact you joined earlier. Oh, we appreciate that. So my name is Gloria, and I'll be the one anchoring today's section. I'm here to support my woman. Women supporting women. Please, we have any other lady in the house? Please, please, please react. It's not just guys, you know. Quinta, I can see you. Yes, yes, we are here to support our own. Thank you very much. So we'll be kickstarting the lightning section tonight. And our host is someone I respect so much. She's a mentor. She's a go-getter. She's someone that inspires me a lot. So I wouldn't want you to take this section for granted. If you have any questions, try to ask for clarity. I'm confused. Okay, try to ask for clarity, and she'll try her best to explain to you. So today's topic is defending design, and it's not about Java, right? Securing Java Enterprise API. So I believe you're going to learn a lot. So like I always say, you can always unlearn whenever you're in a gathering like this, so you can relearn and learn again. So without wasting much of our time, I want you to react with your favorite emoji. I don't know, maybe you can just call me Lady Emoji Sha, because I love emoji a lot. As I welcome no other person than my own partner, my friend, and my mentor, Rosemary. Please have the floor. Thank you.
Good evening, everyone. Good evening, Glory. Thank you so much for that powerful introduction. I'm flattered, seriously. Sincerely flattered. Thank you so much, me, and I welcome you to today's lightning section. As promises to be brief, straight to the point, and actionable. Please confirm if you can hear me before I proceed.
Yes, we can hear you.
Okay, thank you. Thank you so much. Please, if at any point you can't hear me, call my attention. Nena. I'm an Igbo girl. Maybe at the course of this presentation, you'll find out why I told you I'm an Igbo girl. Yeah, that's on the lighter notes. I work with white label technologies. I'm a Java backend engineer, and today we'll be talking about defensive, applying the OWASP top principle to secure Java Enterprise APIs. Yes. So OWASP, please, have anyone heard about OWASP before, or what it does? You can just raise up your hand, and not raise. You can just unmute and tell me. Maybe you know the represent and stuff like that. All right, Chino. So do you want to share your? Okay, go ahead. Yeah. So OWASP top 10. I want to say principle, but somebody here is standing firm against it that they are not principles, they are rather called vulnerabilities or stuff like that. So it's about the open worldwide application security. Oh my God, what am I saying? Let me look at my slide. Yeah, the top 10 principles that have been created based on um, based on issues that like over time that the mistakes most developers make that exposes applications or systems to maybe attack, whether intentional or unintentional. So this topic is extremely very important because most of the real world application we know have suffered security breaches. You don't want to know how much most banks, especially in Nigeria, not just bank or many apps, even most startups have folded up as a result of some of these attacks. And so these security breaches, they don't just happen because the hackers or fraudsters, like I would like to call them, are geniuses. No, that's not the reason. They actually happen because we, the developers, we, the engineers, we trust too much. We trust too much. So that's why it happened. We assume that user inputs are safe. And sometimes we even forget to think about security early enough in the design process. So today we are not just going to be talking about those hacking techniques. No, we are just going to be a mistake that causes us big security problems and how we can fix them properly using secure design principles. Yeah, so the OWASP sub 10, they are not just a list of rules. They are not just list of rules, but these are just the most common ways that application fail in real life. You understand? Like I said, this principle of vulnerabilities, they came up with it based on the mistakes that we developers have made over time. So they came up with other ones, but then these ones I'm going to be mentioning or talking about are the top 10. So it is based on the patterns of mistake that, like I said, developers keep repeating over time, based on maybe their API, their architectures and design and all of those things. The first one is broken access. Broken access, I believe, is something that, yes, please, thank you. It's something that we are all very familiar with. Of functionality being accessed without proper authorization check. So let me give an example. For example, you are trusting a client's data too much, too blindly. Okay, let me use like a banking sector for example. Let me on the screen, if you can look, you see there's an API to fetch all accounts based on the customer's ID or the account ID, I mean to say, based on the account ID. So if the back end now, for example, checks that logged in, yes, user is logged in, boom, you grant them access to this endpoint because you only checked if the customer is logging. That's authentication. You did not bother to check, does this user have access to view this endpoint or not? Just trusted that, okay, since it's a logged in user, let him just access this endpoint. Now let me bust your head. Do you know that the customer can easily change this ID? Let me assume the customer's ID was 1011. The customer can say, okay, that means there will be another the next customer will be 101. And when he adds that ID there, you see he has manipulated your data. Now you have allowed the client side to manipulate your data. You understand? Normally, what you are supposed to do as a dev is, okay, you first of all check, is this user logged in? Yes. Okay. Must this user have the right to access this particular resource? This endpoint, does he have the right to access it? You have to ask yourself that question. If he doesn't, bounce him. Oga, you don't have the right to access this. You understand? So let me give another example with back office scenario. Like I'll still use the banking system. Like in the to apply for some certain things, let me take a loan for instance. When you apply for loan, I think there are like workflows in the bank based on the particular, but every bank have their own workflows. So the first time maybe okay, the loan comes from those marketer guys that go to sort seek for customer to collect loan in the bank, and the oga might okay, this loan we have checked the customer whatever, proceed to the next person. Operation now goes to do their own, approve or decline before maybe the third person, maybe the manager or the MD now approve. So if the manager is the last person to approve the loan or to see some certain files, the marketer guy the loan customer does not have any business to access or see the resources that the MD is supposed to see. So all of these things, this is when your access control come in. That you can log into a system does not give you access to all the resources within that system. Sorry, I don't want to be using different code examples. I don't want to be using code examples because I know we've seen a lot, but I just want this to be hammering in our head while we write the next APIs, of course. So the fix is very simple. Always validate on the server side. Always validate, and never ever trust client side data for any reason at all. And then check for ownership. Don't just check for permission. Always check for ownership. Always. So always check for ownership. Like I said, being logged in does not mean he has the permission to access certain resources. No, they are different. Then go to the next one, which is the cryptographic failures. So the cryptographic failure basically is around what they call it. It happens when sensitive data is not maybe properly encrypted. For example, maybe imagine storing your password as a plain text, like if your database is compromised or something. Like, in fact, even if your database is not compromised, it's a very terrible practice. At no point should you store data, password, your pins, or any important pin that can be used to approve transaction or that can enable someone else other than you, other than the of the account or resource gain access. No, don't. Always encrypt it. Always encrypt it. And then what causes some of these things, like I said, is storing a password as plain text, and also maybe using a weak hashing algorithms. So in order to fix this problem, I think the most common thing that I know for Java, I think not just Java, is bcrypt. So when when you're storing your password, you use bcrypt. And also for data in transaction, please use TLS encryption, and never ever store raw secrets. Never, please. And also, they said there's one thing that my boss used to say, that security is not just about protecting your firewalls, that it is also how you store your data, transmit them. So when you are exchanging data both from the client or the server side, how you store them, if they are sensitive data, it is always highly advisable that you encrypt your data with strong uh, encryption algorithms. So always and the way you also store your data, like I said, it matters. Then we have the most common one that I think is very common among hackers and attackers, or fraudsters, like I like to call them. It's please move to the next slide. Yeah, thank you. It's injection, like SQL injection. So like untrusted inputs manipulating databases or system commands. So what is injection? Basically malicious inputs that alters intended database queries or system commands. So the most common mistake is using string concatenation for dynamics SQL queries. I know that a lot of people are very guilty of this, even though we give Spring what's it called, Spring JPAs and prepare statements and stuff like that. But look at the example on the screen. Like select from users where email is this the concatenation of email. That means you are allowing, that means in fact whatever the user imputes on his own end, that's on the client side now, it is going to, that is what is going to determine the action or reaction of your system, and it is a very bad practice. And to in order to fix it or to avoid this, always, for those in, okay, we are all Java devs, JPA repositories, prepared statements, and parameterized queries. Yeah, so never allow user input or customers input to control your own logic directly. Never ever allow that. User inputs, the way coronavirus, that's the way you should be scared of user inputs. Don't trust them. Hope I'm not too fast, please. I'm a bit okay. So thank you. Yeah, so it's the fourth one is please move to the next slide. Insecure designs. So security is from lack of proactive threat modeling and boundary definition. So this is like one of the most dangerous categories, because design, like we all know, happens before the coding itself even starts. Designs, it is design first. When there is a feature that we need to be okay, system design, do this one, do the design first. So when you want to design your system, think, have it in mind that okay, design it in mind with okay, there's somebody somewhere that is planning to attack your system. In fact, assume that users will break your system. Just have it in mind. If you have this at the back of your mind at the point of design, 60% of your security problems will be solved. That is not to say that there's any system without any gaps. So I don't think there's any. Even the best of systems, still they still have those hackers or fraudsters, like I like to call them, still have finds a way to infiltrate into those systems. But then if when you are designing the system you say, oh, there's somebody somewhere that is trying to break this system, then it will against those risks. Okay, a little story. They might not be related, but then I'll still tell the story. I'm the speaker. Sorry. Yeah, so I remember our first tax. By the way, Mr. Shego was my mentor, my teacher, everything. So he gave us this tax. We should just simply create a system that a create account, log in, and also be able to create tax and update their status to either pending, in progress, and all of that. So we finished the tax. We were a team. We were so happy. We tested it based on this. Oh, we can create account, we can log in, we can create tax and all. So then all of a sudden, oh, for nowhere, Mr. Shagun said, remove this at the point of account creation. Please remove this at, let me assume, queen@gmail.com. Remove the at there and just do queen@gmail.com and send the request. And that was how we removed that. Oh. They say request, account created successfully. I think that was the first time that I know that. Well, think of it. You gave us assignment to do create account. Why will you want us to remove the at there? What? What is the problem? It was a funny experience, but believe me, that never left me. Since that day, you see that validation, what is it called? Uh, at email. I know they play with them. I must always add it at any. So not always, Sha. Sometimes I think I forgot it. Recently, my team lead reminded me. Yes, and I remember that incident, and I think it's a very good check. Always, always. Some of you, your system that you built, if I want to put in phone number, I can put in 080 Rosemary. 945, and it will pass because you are trusting that the user will always have sense to send 081402222. No, they will not. They will always intentionally or unintentionally try to break the system. Sometimes it might be intentional, sometimes it might not. So how do we solve this thing? Like I said, at the point of design, consider everything: rate limiting, no threat modeling, no trust boundary, ownership check, even as much as planning how to handle failures. Let's assume you are trying to make a call to external APIs. For instance, now you want to make checks for BVN verification of a user. Remember that you have to make an external call to a third party API, like call ID, you verifying the rest. If you make a call to that call to verify the customer's BVN and call ID did not respond, or you verify did not respond, what happens? Does your system crash, or do you handle these errors gracefully? All of these things you have to design. If you have them at the back of your mind at the point of design, implementation will solve, and then you have little security issues at the end of the day. Like I said, design for failure. Don't just assume it will always work like I did when we were doing assume. And also assume that users will always try to break your system. It will help you a lot. Model threat early. Security is not just a feature. It is not just a feature. That is why Spring Security, if we decide to talk about Spring Security today, let's say we start today, I don't think we can finish in 3 months, can we? Because it is very broad, very, very broad. So security is not just a feature, it is an architectural decision. Like, it's a design decision, it is everything decision. When you think the product, think the security. I heard that 70% of the startups that folded up today is as a result of all the security issues and glitches. They were either attacked or this happened and that happened, and they folded up. And we don't want that. And there's also one thing I want to say. If you have ever worked on a system that has been attacked, or maybe attacked by all these fraudsters or attacker, he has a way of, like, your pride will just calm down. Ah, you don't want to be part of a team where these things happen. So when you get to your stand up tomorrow, or for those that are not yet working, or you are working on that personal project, please think security. The security misconfiguration. So please move to the next slide. Yeah, security misconfiguration. So production systems running with insecure default configurations. So this happens when maybe systems runs with unsafe default settings. Like in Spring Boot, I know I have a lot of default settings. With like what is this? Your Spring Boot attractor endpoints open in productions, exposing like health information, system config, environmental variables. No, that is an error. Not let that happen. So in order not to be part of those that, in order not to experience this, always restrict your endpoint exposure. Lock down production configs. In fact, disable any defaults that not intended in production. You don't have any reason exposing it. You don't have any reason at all. Yeah. So the sixth one is outdated components. Outdated components. So what is this? So security vulnerabilities in third parties library and frameworks. So this actually happens um, when you use outdated libraries with known vulnerabilities. So let's say, for instance, your pom.xml file now. I know that if I should check some of our project now, you see your pom shouting somewhere, 7 vulnerabilities found in this dependency. But because we feel that nothing is going to happen, we just ignore. You see 250, for those that have very large projects, you see 25 vulnerabilities or 100 found in this project, but we still don't want to ignore. I don't want to talk about those that are still using Java 8, please, so that they will not come for me. So you don't know that the disadvantage of all of these things is that these people have moved on. So they have moved, the people that are working on these things, they have moved on. So as that you even have, there will not be enough support for this your outdated one because they have moved on to the most recent one. So all the security issues they discovered in the previous version, they would have improved on it and worked on it in the next one. So always try to update your libraries. Always try to update your libraries to the recent updated version. That's going to save you a lot of issues. So if you are guilty of this, please, as after this section today, make sure to update your libraries. And you can do your, oh my God, time flies. Okay, I'll be fast. So security is not just about your code. It is not just about your code. It is about everything on your code, including your pom.xml file that you're always ignoring, that shouting, that warning on top of the pom file telling you that, okay, this thing have the security vulnerabilities. You should. So the next one is, let's move to the next one, please. The next one. Okay, let me just use my identification and authentication failures. So this thing has to do with insufficient authentication controls, allowing attackers to compromise user attack. So this is just, in simple English, it has to do with weak authentication logic. For example, weak password rules. What is 12345? No, don't allow that. Help your users stay safe by enforcing strong password rules. It should be a combination of digits, alphanumeric, everything robotic will join together. And also poor section handling. Poor section hand. Do you know that in some applications today, an attacker can hijack the section of a customer, intercept it, and do whatever he wants to do with it? Then talk about token management, bad token management, or inadequate credential verification and stuff like that. Or I'm missing validation as well. I'm trying to hurry up. Our time is fast spent. So the fix for this is always use a strong authentication with Spring Security, proper section handling, and proper validation. Always. Please, before you allow anybody gain access into your system, please make sure you handle all of those uh, stuff very well. An outsider should not be seen, should not be able to see your section or maybe your JWT on the web. I think that's a very bad practice, if you ask me. So the eighth one is software and data integrity failure issues. So the risks from insecure deserialization or untrusted data, or even updates in API. What this is just talking about is talking about trusting data too much. Like I always say, don't always trust data too much, especially when it's coming to the client side. If the front end or the mobile people are doing enforcing their own email validation rule, also enforce your own. If they're enforcing that a customer should not be able to transfer 50 naira on the mobile, they should transfer at least three figures, that's 100 naira. As they're enforcing their own there, you too enforce your own, because some of the time these attackers, most of the time these attackers do not even use your application. They just intercept it with whatsoever it is they use to intercept and do their thing. So this is where your back end validation now come to place. So always validate the data that that comes to your system. So using you can use a Java native, sorry please. For instance, if you are using Java native serialization or on external endpoint, it will easily allow attackers to inject malicious objects into your system. We don't want that. The fix is very simple. Always validate your payloads 247. Always at not whatever, at blank, at not null, at maximum of this, at it must be. You use rejects, use anything, validate payload, validate your DTO, be very strict with them, ignore unknown feeds. I know some of us now, if I go to our system and put in let's assume what your system requires to log in is email and password. If I send email, password and let me say OTP, it will still accept it. You are not even validating what's coming to you. You just pick the one you want and you go. So that's a very bad practice, and you shouldn't trust data that come from the client side. If you don't trust the source, you don't have any reason trusting the data. So the next one is logging and monitoring failures. So security logging and monitoring failures. Do you know that sometimes a system might have been attacked, and even months and months and months later, the people that build the system and the people using the system will not know that their system have been attacked. They won't know because of inadequate logging. And I think my last section here was on logging and auditing in Java. You should check it out. It's on YouTube, on how to log actionable data and audits in your system. So always log, like I say, always log. So because sometimes this thing happen and nobody notice, and it's very simple because there are no logs, there are no alerts, no monitoring system or something that is being enforced anywhere. There's not even a security event that is being triggered. For instance, if you notice, if someone is doing something, okay, let me just give a simple example. You have a customer in your system that, okay, usually he logs in with this particular device on this location. Then one day he suddenly logs in US. Meanwhile, he's in Nigeria, US with a different device. You should your system should be able to dictate some of these practices. Send an email, oh, their customer, now you log in for US, I say Nigeria. If not be you, if not you, it will help secure our system very well. So please always implement monitoring, structured logging, not just logging that will fill up the whole space. Actionable logs, actionable logs for security monitoring. Always add your audit trail. Audits in the sense that always capture who did what, why did they do it, when did they do it, and what was the result of what they did. So that's what audits are more like, straight to the point, and they provide at a glance. You should be able to know what happened, and also add alerting systems to your systems. Yeah. If you don't see the attack, there's no way you can stop it. Yeah. So the last but not the least is server side. Um, Please, can you go to the next slide? Okay, security, server side request forgery. This happens when servers make requests based on user inputs. Very bad practice, like I've been saying from day one. So let's say, for example, an API that accepts a URL and fetches data from it without proper validation. Attackers go finish the system with that. So an attacker can force your system to access maybe internal systems, and we don't want to allow that. I know that recently ChatGPT URL, and they will go to fetch whatever it is that you ask them to fetch. But do you know the amount of security or the amount of system or things they have put in place to have allowed this? Because note that previously they don't used to do this, but now I think they do. I don't even think they do. They actually do. So the fix for this is URL whitelisting. Not whitelist, allow listing. Then strict validation, never trust user supply data, always validate them and stuff like that. And that's the last one. So to round up, these principles that I just mentioned, they just teaches us something very important, and which is that security are mostly cost. We trust the client too much. That is simple. Security issues happen because we trust that the client will always do the right thing, always. And for that reason, security must live in our design, in our architecture, service layer, validation, monitoring, logging, everything. Security. Think about security in all of these aspects, not just in your code. So with this, I want to thank you everybody for listening. Sorry, I took so much time. I think I'll be done I thought I'll be done in 30 minutes, but I was just seeing 7 minutes left. Thank you so much for listening. If you have any question, you can ask. If I don't have the answer, somebody in the group chat in the meeting will answer your question. If you want to share your experiences and stuff like that, we can continue on the group chat. Thank you so much, everyone, for joining.
Thank you very much, Rosemary. Maybe what we'll just do next is to increase your timing from 1 hour to 2 hours. So we don't really appreciate your time. So we don't have much time. We'll be taking a basic question. If we can mute and ask your question.
I have questions too.
Someone mute yourself, please. Don't interrupt me. Ebube, can you hear me?
Yes, I can hear you. Good evening.
That's your question.
Hello, can you hear me now? Good evening.
Yes, we can hear you. You can ask your question.
Okay, sorry. My good evening, Mrs. Rose. My question is on you said like it is bad practice to use native Java serialization. I've always said that thing, and I don't understand why. Like why shouldn't you use native Java serialization? And does it mean that the serialization being done by libraries like Jackson is not using native serialization? And if so, what are they now using?
Okay, so before I answer, does anybody within the team or the group have the answer to his question? So by saying that during my presentation, I said, is there a reason why we shouldn't use native Java serialization? Okay, it is simple. The course of my research, I found out that this native Java allows object to be sent like in raw data, and then they can be reconstructed. You understand? Because native Java, they, like I've been saying since, they trust too much. And remember that our goal is not to trust the data or even the source of the data at all. Yeah. So it trusts too much. And you also know that when you serialize the method or an object, you are automatically executing internal methods within that object. I hope I answered your question. And if I did not, we'll meet in the group chat. I can answer.
Everybody, are you satisfied?
I'm mostly satisfied.
All right.
But like
So,
she didn't answer the one on Jackson. Like what like the external libraries now that we use to do serialization, how are they not achieving it? Like
So that
I
is the
did
problem
like
now.
how would they now serialize data? Is it that they are doing it in a way that is enclosed, that is not able to reach the system and make changes to the code?
And so, the sincere truth is that I've never cared to know what they did differently. I just knew that they were safer, and I decided to explore that option. But if anybody wants to answer the question, please, they can go ahead to answer.
okay. Ikechukwu can go ahead, but he will make it very brief because we have limited time.
I just wanted to say that the native serialization had to do with turning the object into a stream input and output. And before, it was very used in everywhere, applets, log4j, and a lot of projects. And they discovered that it led to a lot of remote code executions and some kind of vulnerabilities that came along. So that was why a lot of Java projects have actually dropped it. they have removed it from their, they are doing their best to remove it, even the legacy ones. And then we have the Jackson one. The Jackson one serialization is different from the one that the native Java has. So serialization is basically just turning the objects that we have into a format that we can easily exchange. JSON, it could even be a protobuf, I think. But it's different from the actual native serialization. So Jackson serialization is, it passes your Java object to create a sort of parse tree that will be used to form a JSON object or a JSON
All right,
string.
thank you very much, Ikechukwu. We have less than a minute. Ebube, you can follow him up on the group. So thank you everyone for joining today's section. We really appreciate. We'll be meeting again on Saturday this week. And thank you so much, Rosemary. For those that are yet to join the community, the social media handles have been dropped in the group chat. So you can quickly copy them or the meeting ends. So we're going to call it a night. Samuel, you can ask your question on the group.